8th Standard Mathematics, Chapter 7, Variation, Module 2. In this module, we'll study about the inverse variation. Let us first understand what is an inverse variation. The statement y varies inversely as x means that when the value of x increases, y decreases by the same factor and vice versa. That is, if y increases, x will decrease. X inversely varies as y is written as x inversely proportional or in inverse variation to 1 upon y. So inverse variation, we write it as the form of reciprocal. Now, if x is inversely proportional to y, it's written as x inverse proportion 1 upon y. And in form of equation, this is written as x is equal to k upon y. If we take y on the other side, this will become x into y equal to k. This is the equation of variation, and k is called as the constant of variation. Let us see an example. If A varies inversely as B, then we have to complete the following table. So let us start with the solution. A is inversely proportional to B is written as A inverse proportion 1 upon B. And the equation of variation will be A into B equal to K. First, we will find out the value of K. So in the first column, A is 6, B is 20. Substitute it in the equation of variation. Your value of K will be 60 multiplied by 20, that is 120. So the constant of variation is 120. Now, if you see in the second column, value of A is 12, value of B has to be found out. We'll use this and the constant of variation and our equation of variation to find out the value of B. So A into B is equal to 120. Substitute the value of A, that is 12. So 12 into B equal to 120. You divide both the sides by 12. Your value of B will be 120. B is equal to 120 divided by 12, which is 10. The value of B is 10. If you see the third column, A is 15. Value of B has to be found out. And even A into B has to be found out. So we know A into B is 120. We have already found out in the first part of this question. So A into B 120. Substitute the value of A, that is 15. So we have 15 into B equal to 120. Divide both the sides by 15. So your value of B equal to 120 divided by 15, which is 8. So in this case, B equal to 8. If you look at the fourth one, again A into B, that is this column here will be 120. We need to find the value of A when B is 4. Use the equation of variation. A into B equal to 120. So A equal to A into 4 equal to 120. You divide both the sides by 4, you will get A is equal to 120 divided by 4, which is 30. So the value of A is 30. Exercise 7.2, the second sum. So in the second sum, we have to find a constant of variation and write the equation of variation for every example given below. So we have 4 subparts in this question. Let us find the solution of each of the subparts separately. So in the first one, if you see, P is in inverse proportion to Q. So we have P inversely proportional to 1 upon Q. So this in the form of equation will be P is equal to K upon Q, where K is the constant of variation. Now in the question it is given P is equal to 15, Q is equal to 4. Substitute this in the equation of variation. So we have 15 is equal to k upon 4. You multiply both the sides by 4. So you have k is equal to 15 into 4, which is 60. So the value of k, that is the constant of variation, is 60. Substitute this in your equation of variation. You have P is equal to 60 upon Q, or PQ equal to 60. So our constant of variation is 60 and our equation of variation is PQ equal to 60. The second one, it is said Z is an inverse proportional to 1 upon Q. If we write this in the form of equation, we have Z is equal to K upon W, where K is the constant of variation. Z is given 2.5, W is given 24. Substitute this value in your equation of variation and find out the value of K. So we have 2.5 is equal to K upon 24. Multiply both the sides by 24. You have K is equal to 2.5 into 24, which is 60. So the value of constant of variation is 60. So the equation of variation, you substitute the value of K as 60. So we have Z is equal to 60 upon W, or ZW is equal to 60. So our constant of variation is 60 and our equation of variation is ZW equal to 60. The fourth one, X is an inverse proportional to 1 upon root of Y. So in the form of equation, this will be X is equal to K upon root Y, where K is the constant of variation. Now in the question, X is equal to 15 and Y is equal to 9. Substitute the values of X and Y in your equation. X is equal to K upon root Y. So we have 15 is equal to K upon root of 9. We know square root of 9 is 3, so we'll substitute that as 3. So we have 15 is equal to K upon 3. Now you multiply both the sides by 3 and you get K is equal to 15 into 3, which is 45. So the value of K is 45. Substitute the value of K in your equation of variation. So equation of variation is X is equal to 45 upon root Y, or X into root Y is equal to 45. So our constant of variation is 45 and our equation of variation is X root Y is equal to 45. Question number 3 of your practice set 7.2. The boxes are to be filled with apples in a heap. If 24 apples are put in a box, then 27 boxes are needed. If 36 apples are filled in a box, how many boxes will be needed? Clearly, this is an example of inverse variation. Let us understand and write what is given. If the number of apples in the box is increased, then the number of boxes will decrease. So if number of apples in one box is increased, we will require few number of boxes to pack the apples. So number of boxes decreases. So the number of apples filled in the box and the number of boxes will be in inverse proportion. Now since we know they are in inverse proportion, we'll let the number of apples filled in the box be denoted as a variable X and the number of boxes be Y. Now since they are in inverse variation, X varies inversely as Y, that is X inverse proportion 1 upon Y. And in the form of equation, this will be X is equal to K upon Y, where K is the constant of variation. We'll take Y on the other side and you'll have X into Y is equal to K. Now in the question it is said, if 24 apples are put in the box, then we require 27 such boxes. So when X equal to 24, Y equal to 27. Understand the meaning of this. I'll repeat it. It is said, if 24 apples are put in one box, then we'll require 27 such boxes. So when x is 24, y is 27, using these values of x and y, we'll find out the value of k. So k is equal to 24 into 27, which is 648. So the constant of variation k is 648. We'll substitute this in our equation of variation. So xy is equal to 648. Now in the question they have said, if you want to fill 36 apples in one box, then how many boxes will be needed? So when x is 36, we need to find the value of y. So substitute the value of 36 in your equation of variation. So we have 36y is equal to 648. Divide both the sides by 36 and you'll get y is equal to 648 upon 36, which is 18. So 18 such boxes will be needed. That means if you put or if you fill 36 apples in one box, you will require 18 such boxes to fill all of the apples. The fourth sum of your practice set 7.2. We have to write the following statement using symbols of variation. So the first one is the wavelength of sound denoted by L and its frequency denoted by F are in inverse variation. The second one, the intensity I of light varies inversely with the square of the distance denoted by D of a screen from the lamp. Let us start with the solution. So the first one, the wavelength of sound L and its frequency F are in inverse proportion. This statement can be written using symbol of variation as L inversely 1 upon F. Second one, the intensity I of light varies inversely with the square of the distance of a screen from the lamp. So that means we have to take the square of D, that is distance. This statement can be written using the symbol of variation as L inversely proportional to 1 upon D square. Okay, the reason we are taking D square because it is mentioned square of the distance. Practice set 7.2, question number 5. X is in inverse proportion to root y. That means x inversely 1 upon root y. When x is 40, y is 16. This is given. And they have said when x is 10, we have to find out the value of y. Let us start with the solution. It is given that x is inversely proportional to 1 upon root y. So this in the form of equation will be x is equal to k upon root y, where k is the constant of variation. If you take root y on the other side, you will have x into root y is equal to k. This will be your equation of variation. Now in the question it is given when x is 40, y is 16. Substitute the values of x and y in your equation of variation and find out the value of k, that is constant of variation. So you'll have k equal to 40 into under root of 6, and we know square root of 16. Square root of 16 is 4. So you have k is equal to 40 into 4, which is 160. So the value of k, that is your constant of variation, is 160. Substitute the value of k in your equation of variation and you will have x into root y is equal to 160. Now, since you have the equation of variation and the value of k, that is the constant of variation, when x is 10, we have to find out the value of y. So we'll substitute it in this equation. So 10 root y is equal to 160. Divide both the sides by 10 and you get root y is equal to 16. Now we need to remove this root y. So in order to remove this root y, what we will do is we will square both the sides. So squaring both the sides, we get y is equal to 16 square, which is 256. So when x is 10, y is 256. Practice set 7.2, question number 6. Given that x varies inversely as y, when x is 15, y is 10. If x is 20, we have to find out the value of y. So we'll follow the same procedure. It is given x varies inversely as y, that is x inverse proportion to 1 upon y, and in the form of equation this will be x is equal to k upon y, where k is the constant of variation. The equation of variation will be x into y is equal to k. So when x is 15, y is 10, this is given in the question. Using the value of x and y, we'll substitute it in our equation of variation and find out the value of k, that is the constant of our variation, So k is equal to 15 into 10, which is 150. So the value of constant of variation k is 150. Substitute the value of k, 150, in your equation of variation, that is x into y is equal to k. So your equation of variation will be xy is equal to 150. Now, when x is 20, we have to find out the value of y. So we'll use our equation of variation to find out the value of y when x is 20. So substitute the value of x as 20. So you have 20y is equal to 150. Divide both the sides by 20. You will get y is equal to 150 upon 20. And 150 divided by 20 is 7.5. So when x is 20, the value of y is 7.5.